Hello everyone. In this video, we're diving into definite integrals, an important concept in integration. Unlike indefinite integrals, which gives a general function, definite integrals help us find the exact area under a curve between two limits. We'll break down it step by step with clear examples to help you understand. In this video, we'll solve definite integral problems and apply them to exam style questions. So let's get started. In your first example of this question here, they're going to ask you to find the exact value of integration of x minus 1 square over x cubed between 5 and 3, right? So our first step in this is to always first find the integration of this. Now, we do not have a quotient rule to solve integrations. So what we need to do is actually we need to expand the top and then simplify it as a single fraction. So first of all, expanding the top, you have x minus 1 times x minus 1 over x cubed. This would actually equals to x squared minus 2x plus 1 over x cubed. And when we simplify this, x squared over x cubed, you have 1 over x minus 2x over x cubed, you have 2 over x squared. And lastly, 1 over x cubed, you have 1 over x cubed. Okay, from here, what we're going to do is we're going to integrate this and put it in between the limits of 5 and 3. Integrating 1 over x, you're supposed to get ln x. Integrating 2 over x squared, let me remind you that 2 over x squared can also be written as 2x to the power of negative 2, right? So when we integrate this, the negative symbol moves in front, negative negative becomes plus. Then uh, bringing this to 2x to the power of negative 1 plus 1, right, over 1. Then this will become 1 over x cubed. Again, 1 over x cubed can also be written as x to the power of negative 3. So when we integrate for this, it will actually become the negative brings in front, negative x to the power of negative 2 over 2, like so, right? And this is the integration in between the limits of 5 and 3. Now, one thing to note is when you're doing definite integrals or even later when looking for area under the graph, you do not need to have your plus c component. The reason is simple. The plus c for 5 will always minus the plus c of 3, right? Which will ultimately cancel each other off. So from here, just substitute 5 into your equation first. Ln 5 plus 2 to the power of 2 times 5 to the power of negative 1 minus 5 to the power of negative 2 over 2. The first value will always minus the second value here. Ln 3 plus 2 times 3 to the power of negative 1 minus 3 to the power of negative 2 over 2. Okay? From here, simplify where we can. Ln 5 minus ln 3 is actually ln 5 over 3. This will give us 2 over 5 minus 1 over 50. Type this into the calculator. Minus 2 over 3. Then plus 1 over 18. So if you type everything into the calculator correctly, you're supposed to get 52 over 225. This is the exact value for this question over here. Okay. In your next question, evaluate cos x over 4 between pi over 2 and pi over 3. You must show all your working. So first of all, integrating cos, you will get sine x over 4. Then what we're going to do is we're going to have to use this and divide it with 1 over 4 again, right? And lastly, between the limits of pi over 2 and pi over 3. Next step, start your substitution. This is sine x over 4 divided by 1 over 4 is 4 sine x here. 4 sine x, which is pi over 2. Pi over 2 divided by 4 will give you pi over 8. First substitution minus 4 sine pi over 3 divided by pi over 4. Sorry, divided by 4, you're going to get pi over 12. Type this into your calculator, you would have gotten 0.495. Okay? Then, in the next part of the question, find the integration of this. So, to find the integration, what you're going to have to do is you are unable to integrate 1 over 4x minus 3 because this is basically 4x minus 3 to the power of negative 1. So therefore, since we cannot do it like this, we know that it's going to become a ln. Integrating power of negative 1 will give you ln. Ln 4x minus 3, right? But look at here. The mistake that students always make is that they forget that if they were to differentiate ln 4x minus 3, you would end up with a 4 on top. So in order to combat that, what you need to do is you need to have a multiple in front that will cancel the differentiation here. Okay? You need to have a multiple, a constant, to cancel the differentiation here. Okay? Then similarly, this is actually x to the power of negative 3. When you integrate it, you will have minus 1 over 2 because it's the 2 will bring down, and then x to the power of negative 2, since it's negative 3 plus 1, which is just equals to 1 over 2x squared plus c, right? This will be the integration here. All right, next example. Find the integration of 1 plus e to the power of 2x to the power of 2, giving your answers in exact form. So once again, what you need to do is you need to expand the bracket here. 1 plus e to the power of 2x times 1 plus e to the power of 2x. Expanding this, you will get 1 plus 2e2x plus e to the power of 2x times e to the power of 2x. You would have gotten e to the power of 4x, right? Then from here, integrate between 2 and 0, which you will get integrating 1, you will get x. Integrating 2e2x, you would have gotten 2e2x over 2 plus integrating this e4x over 4. Okay? Now, integrate them, substitute the limits between them, you would have 2 plus e to the power of 4 plus e to the power of 8 over 4 minus 0 plus e to the power of 0 is still just 1, so it's plus 1. E to the power of 0, this is plus 1 over 4. Then from here, what you're going to do is just add up the numerical numbers together. Since e to the power of 4 cannot be simplified with e to the power of 8, adding up the numerical numbers 2 minus 1 minus 1 over 4, you're left with 3 over 4 plus e to the power of 4 plus e to the power of 8 over 4. Okay? All right, next part of the question here. Integrating this value giving it in exact form. Notice that all these questions are always asking you in exact form. So a reminder that this actually becomes 3 to the power of 3 times 3x minus 5 to the power of negative 2 is what I meant. Okay, and this one must be done with a ln. Integrating for this, you would have ln 2x minus 3. Now, once again, I ask you to check when you differentiate this, you will get the 2 on top, right? So in this case here, we do not need to have a constant or a multiple here because differentiating this will give me this exactly, right? And I continue to integrate this, the negative 2 bring in front, so it uh, changes the symbol. 3, 3x minus 5 to the power of negative 1 over 1. Sorry, over 1 and the differentiation of inside here. So we times 3. This is our integration between the limits of 4 and 2, which will then cut here. Now substituting it, ln 4 times 2 minus 3, you will get 5, right? Plus 1 over 4 times 3, 12, minus 5, 7. Okay, minus the substitution of this, 4 times 2 times 2, 4 minus 1. So it's just ln 1. Okay, then substituting into this plus 1 over 3 times 2, 6 minus 5 is just 1. 1 over 1, right? Simplifying the whole equation, ln 5 minus ln 1, you will just get ln 5. Okay, 1 over 7 minus 1, you will get minus 6 over 7. Final answer. Okay, pretty simple and straightforward questions here. All right, one last question, one last example that we have. In this question here, find the integration of 5x minus 2 to the power of negative 2 over 3 between 4 and 2, right? So doing my integration first, this is somewhat of a chain rule. So you will get 5x minus 2, negative 2 over 3 plus 1. You will get 1 over 3. The power is divided. The differentiation of inside here is also divided, right? And now we want it between the limits of 4 and 2. From here, just basic substitution. 4 times 5, 20, minus 2, 18. To the power of 1 over 3 can be written as cube root of 18 over 5 over 3 minus the same thing. 2 times 5, 10, minus 2, that's 8. Cube root of 8 over 5 over 3. Okay. Of course, you cannot leave your answers as a fraction over a fraction. So this will therefore change into 18 divided by 5 over 3, which gives you 3 over 5 cube root 18 minus 3 over 5 cube root 8. Okay? And since the question actually never mentioned what specific format they want it to be, this can very well be the exact answer already. Oh, sorry. I noticed that this one can be simplified. So this should actually become 2 times 3. You will get 6 over 5. Then this will be your exact answer. Cube root 18 cannot be further simplified. So this should be your exact answer here. Okay. Then last part, find the integration of this whole thing giving answers in the form of a plus ln b, where a and b are integers. Now, this question, they do ask for a specific format they want the final answer to be. So then we have to try to follow this. Okay, starting off with integrating this, you would have gotten, once again, ln 2x plus 1, right? But when you differentiate this, you will get a 2 on top. So having a 2 to turn it into a 4, you have to multiply it with 2 again, minus the integration of this, sorry, plus 8, 2x plus 1 was negative 2, plus 1 gives you negative 1. So over negative 1 times 2, like so. Okay, then this, you must put it in between 1 over 2 and 0. Substituting your values in, 2 times ln 1 plus 1, this will give you 2 ln 2. This one here cancels to become minus 4 times into the half here. You will actually, again, you will get 1 over 2 times 2, that's 1 plus 1, that's 2 here, to the power of negative 1. Okay, first substitution, minus the second substitution, which is 2 ln 0, right? So it's just 1, minus 4, 0 here, plus 1, 4 plus 4 times positive 1, you will just get 4. Then simplify where you can here. This will become ln 4 minus ln 1, because 2 brings over up here to the power, and then minus the simplification of this, you will get 2. This is plus 4. Your final answer would have been ln 4 plus 2. Final answer here. All right, that's all for this video. See you in the next one.